Hello students, and welcome to our continuing lesson on sinusoidal functions. And in this video we're going to take a look at some definitions and draw some pictures to illustrate those definitions and make better sense of them. So the first definition I have here is a sinusoidal function, and this is any function that can be written as f of x equals sine, and I can do some transformations to this, so it can be written as a sine of bx plus c plus d. Whoops, I should use a red coloring here for the D. And it can be written that way as long as where A, B, C, D are real numbers. So nothing imaginary in here, are real numbers. And this is really just a sine function, but I'm saying a sinusoid is any sort of transformation of a sine function. That's what A, B, C, and D are doing. They're transforming the original function. Okay. So that's what the goal that we're doing here, that we're aiming for here, is being able to take a sine function, the basic f of x equals sine, and then taking that and expanding it to different transformations of them. So before we move on to the next definition, I'm going to make a note here that the parent function, or this is the basic 12 function here, that we're going to use is f of x equals sine of x, and f of x equals cosine of x. Okay, either one of these are going to be the parent functions. So now we can define our next vocabulary. So the amplitude is 1/2 times the maximum value. I shouldn't use this dash, sorry, I'm gonna not use that dash. I'm gonna say max value minus min value. So if I have the maximum value and subtract the minimum value from it, multiply that by 1/2, I get the amplitude. And let's see what that means on a sketch here of a cosine or a sine function. So let's say I have a sine function that behaves like this. Well, in this sine function, the maximum value is at 1. Okay. So this is the maximum value up here. The minimum value here is at -1. So for sine and cosine, I take 1 minus -1 times 1/2, and that gives me 1. So for sine of x and cosine of x, the amplitude is equal to 1. And I'll show the work on the side here. Max minus min times 1/2. Well, that's just 1 minus -1 times 1/2, which gives you 1. Okay. And so let's keep this in mind here, that for sine and cosine, the amplitude is 1. And that's actually very convenient for us as we move on to some of these more difficult concepts here. Next, we have the definition of a period. And the period of a function is how often, now do this in layman's terms first, how often does the function repeat itself? How often does the function repeat itself? Okay. And for the sine and cosine, I'm just going to take these former pictures here to show you. This is the sine function, and we already talked here that the function repeats itself every 2 pi radian. That's for sine. And for cosine, well, pretty much the same rule. 2 pi. Down here it repeats itself 2 pi. So for both sine and cosine, for the parent functions, p, or the period, equals 2 pi. Okay? And keeping these things in mind is very important as when we move on to some transformations. So that's the period. Next is the frequency. Frequency is how many periods are in one unit. So in one unit, how many full periods has been completed? Well, if we look at the sine and the cosine functions, this is where sine is, this is pi right here. This is 0. Okay. This right here is pi over 2. No, sorry, not pi over 2. This is 2 pi. And we're saying, look, wherever one unit, that's about right here, how many periods have been completed in this section alone? Okay. Well, that's just the reciprocal of the period. So another way we can define this is that it's the reciprocal of period. So frequency is equal to 1 divided by p. And we can also state that for the parent functions, and again, parent functions are important because they help us to get all the other functions. The period is equal to 1 over 2 pi. I'm sorry, the frequency is equal to 1 over 2 pi. The period is 2 pi. Frequency is the reciprocal of that, so that's 1 over 2 pi. Okay. And to recap a little bit here, sinusoid is a sine or a cosine function that we can do transformations on. And the amplitude, which is the difference between the top and the bottom times 1/2, or you can also view it as the difference between the top and the middle. For the sine and cosine, it's 1. The period is how often does it repeat itself? Well, it repeats itself every 2 pi radian. And then the frequency is the reciprocal of that. Okay, so we'll use frequency a little bit. We're going to talk about amplitude and period quite often. Now the next thing we're talking about here is the phase shift, which is kind of a slippery concept. When we try to explain it in layman's terms, we can define it very clearly in mathematical terms. So let's do that first this time. So the phase shift is defined as follows. If we rewrite a sinusoid to be in the form, I'm sorry, that's terrible grammar, to take the form f of x equals a sine, change colors here, b x plus h plus c, then the phase shift is this value right here, okay, is h. Okay. That's the phase shift. In other words, if we take a sine function like this, a sine bx plus c plus d, and we factor out the b here, so we factor it out so that x has a coefficient of 1, whatever it is that's being added on to x in the parentheses, that's the phase shift. And let me explain that a little bit, sort of in layman's terms. And this is really the horizontal shift of the parent function. Once we're talking about this part right here, where it's bx plus c, that's no longer the parent function. The phase shift is the horizontal shift of the original parent function. Okay, and if that's a kind of a weird and abstract concept for you to see right now, that's okay. I want to get the definition out there. Make sure you have it written down correctly, and I'm going to come back to it later as when we're talking about transformations. Now, the next and final vocabulary word here we have is the vertical shift. And the good news is that the vertical shift is very straightforward, like all things in transformations. Vertical is straightforward. And this is the upward or downward shifting of the original parent functions. In other words, it's D. However much it is that you're moving up or down, that is going to be the vertical shift. Okay? So let's say I had a function like this. If I had a function called, we'll use sine for now. So this is f of x equals sine of x. And remember, this point is here at 1. This point here is at -1. If I create a new function, if I take this and I go g of x equals sine of x plus 2, then that means everything in here is going to get shifted up 2. So the new picture that I would have is now, instead of being at -1, it's going to be at +1. And instead of being at +1, it's going to be at 3. And so now I have a function that looks like this. Oops, let me draw that better. Okay. So this is the max value now at 3. And this is the min value here at 1. And this right here is the vertical shift. And that's probably the most straightforward out of all of these concepts. I'm going to go back to create another video where we look at some examples where we're graphing this in GeoGebra and your TI-83 calculator. But for now, these are the concepts that we want to worry about for transformations: phase shift, vertical shift. Okay, we haven't described what A and B are just yet, but we will talk about that in the next video.